So there were a few questions in Basics A that people had issues with, and so I dug a little deeper, and this is what I found. The first question is here, number six. It's number six that's after number five. Okay, and it says the Java compiler translates Java code to bytecode. This is true. That's what it does. Translates source code to bytecode. It creates classes. That is true too. Java compiler creates a set of classes, creates executable files. That is true as well. And then D produces the Java interpreter. That is not true. So the Java compiler does all these three things and then gives the bytecode, which is zeros and ones, a set of zeros and ones, to the Java interpreter. And the Java interpreter is something that you download. So we're over here, and I'm doing searches on Java C. That's the Java compiler. Do I need a Java JVM, which is the virtual machine? This is the interpreter. And let's see, what are we talking about here? Okay. So Java compiler produces Java class files, which is then given and run on the Java virtual machine. And so it becomes a little bit obvious because of the fact that you need to download the Java virtual machine, which is a different program based on what platform you're running your Java files on. So if you're running on a Windows machine, there's a certain Java virtual machine, and then if you're running on a Windows machine and a Linux machine, then there are different Java virtual machines that you need to download. So my vote, although it's not gospel, would be that number 6 is an error, and E should be above D, right? So then all of the above, these three, are correct and not D. Again, not gospel. And then I'm going to go ahead and move on to the next question, which is this one here. We have an inheritance hierarchy with novel and textbook. Book is the superclass, novel is the subclass, textbook is the subclass. So which of these false statements about the class is shown? The textbook class can have private variables that are neither book nor novel, that are in neither book nor novel. That's true, right? So this guy here, the child, can have private instance variables that aren't in book or novel. And then number B, each of the classes, these three, have a method, compute shelf life, whose code in book and novel are identical but different in code in textbook. So although this is kind of a tricky question, because why would you have the same method here in book and the same method here in novel with the exact same code? The question isn't why, the question is could, right? And so you could have that. You could overwrite the book's compute shelf life down here in novel and rewrite it with the exact same code. That's possible. Not logical, but it's possible. And then different here in textbook. And so that is true, right? You can do that. So B is not false. And then we got C. If the book class has private instance variables, title, and author, then novel and textbook cannot access them. That is true as well, right? So then if the superclass has private instance variables, you need to have public what's called methods, right, in order to get access to those variables. So get A, write A, right, or set A, getters and setters, down here so that novel and textbook can access them. And so any private instance variables, methods that are going on up here in book cannot be accessed down here in novel and textbook. They can only be accessed by methods in book. And then number D, both novel and textbook inherit the constructors in book. Let's skip that for now. And number E, if the book class has a private method called readFile, then this method may not be accessed. So that's tied with question C, right? So instance variables and methods, private methods, cannot be accessed by child classes. So that brings us to D. D must be the false answer if this question is constructed correctly. And it is. So novel and textbook inherit the constructors in book. That is not true. Why is that not true? I guess the why is because Java was designed that way. So it's kind of like a sky is blue issue. And then another way to think about it is the book constructor is called book, right? So then when we come down here to the novel constructor is called novel. So then you can't inherit the book constructor as the novel constructor because the novel constructor has a different name. So just thinking about it in that way, it doesn't make sense. So just kind of sky is blue. That's the way it is. And then Blake ran a experiment where he created a book class where the constructor said something, or set a value to the value 5. And then in the novel class, he didn't write a constructor, and he just did a static void main. And in the static void main, he printed out the value of value, right? So then there is no value instance variable here in novel. There's only one in book. And so that's all he did here was static void main, print out value. To test if the book constructor was being run, he ran it into our dismay and awe. This static void main printed out the value 5, which was set up here in the book constructor. So we're thinking, what the heck's going on? And what is going on is that the parent constructor is run automatically when you are dealing with the child class. So that makes sense too, because since the parent instance variables are a part of the child classes, the instance of the child class, you have to run the constructor of the parent in order for the parent's instance variables to be initialized. So for novel to have them and to have them available for use, the book constructor must be run, right? So that's happening magically in the background, something you need to understand. And then the novel class, what we did, here's another point of confusion, is what we did is in our novel constructor, we ran super. So that explicitly ran the book's constructor. But we didn't need to do that, right? So we did that to be explicit, but we don't have to do that. The only time we have to do that, run super here in novel, is if the book's constructor requires arguments, right? So if the book's constructor requires arguments, down here in the constructor of novel, the first line is super, parentheses, and then a set of arguments are being passed to the constructor. So that's that. And then what? Then we have this one over here, number 1. It's before 17. A large Java program was tested extensively. No errors were found. What can be concluded? This one was a curveball. So all of these questions we're going over are curveballs. And so what can be concluded? All of the preconditions in the program are correct. Preconditions means conditions for the input that the program is being given. I'm sorry, for the that the method is being given, right? And so we cannot. That's an impossibility. So this statement here is an impossibility. That's the idea is that you can't test for every possible precondition. And then if you don't know all the different possible preconditions, right, then you cannot know the possible postconditions because you don't know you haven't tested all of the possible inputs. You can't know all the possible outputs because of that, right? So these two are tied together. Now, if this question was worded in such a way where it says a large Java program was tested and all preconditions was tested in a way that all preconditions were tested for, then what could you conclude? You can conclude that this B is correct, okay? Okay, and then we got number C, the program may have bugs. That's true. That may be true. That may not be true. You cannot conclude that, right? So C and D are out of the picture. And then E, every method in the program may safely be used in other programs. Here the keyword is safely, right? So tested extensively is kind of a strong phrase, but it's not absolute. And then safely is a strong phrase, but it's not absolute. And so the answer is E, that it may be safely used in other programs. So if you're like a quality engineer, a quality assurance engineer, safely is the best that you can shoot for, right, when you're testing. So again, another curveball question. And then we have another one down here. Where is it? Number 12. Give me a second here. It's right here. Okay, this guy here. So then this guy here, we're assuming they're type double, and actually I'm not 100% on this one, but Yeah, maybe one of you guys could do it. What I did is I put it with the x as a 5 and y as a 6, and I ran through this algorithm. And the only way this works out is if the only way this is true is if x is equal to y. So I chose C. Again, this is a 50%. I'm putting 50% on this one. I'll keep thinking about it, but again, this one, maybe you guys can think about it and prove me wrong or prove me right. Yeah, so there we go.